Okay? Can you hear me? Is that okay?
Yeah, you can also.
I need to use this one?
This is for inside.
Okay, this is for the recorded. Okay, thank you. So nice to meet you all. All right. I will have two presentations today. One concerning OpenPOWER Foundation. We just got a summit yesterday and Monday and Tuesday. So there are a few summits per year occurring on each main continents, China, Europe, and US. So I'm presenting on behalf of people who are in charge of the foundation. So I'm working currently for IBM in France, and IBM, of course, is one main contributor for the OpenPOWER Foundation. So open source software has been, as you all probably know, been on the air for several decades now, and it's a long history of different activities that have been developed in collaboration. So here are a few examples, with the most well-known being for sure the kernel of Linux and all these contributions that Linux knows. We have several known open repositories and open softwares that are well known to be used by not only students but also professionals, as we are. So what about collaboration in open hardware? So we are introducing this OpenPOWER subject today, but it's not related to OpenPOWER only. So hardware like Arduino, several schematics around the P development for this small microcontroller. There are several initiatives that tend to propose hardware where schematics is shared and collaboration is welcome for reuse and defining de facto standards for most of the time. So it's not a new area. So the question was, would it be possible to go and apply the same principles that we had for software when hardware is concerned? So the goal is to have something that is reliable. We want to have schematics if we want to use them for high computing servers. We want to have something that has been proven. We want something that is secure, no breach, and something that is transparent, which is the goal of sharing in an open system. Modern software stacks rely on being able to trust the hardware on which it executes. There is we have faith that the components we are using and the hardware layers that we have been proposed are not opening doors in our back. So this is also something that pushes to know as much as we can on the hardware side what's happening. So what can be done? We want to build systems that are entirely open designs, as well on hardware side, as well on software side. So this is the goal of the OpenPOWER consortium. It's the evolution of a proven processor architecture and ecosystem. In the 90s, as you might know, the IM consortium with different chip providers tended to collaborate to propose the first PowerPC. Most contributors, after years, decided to go on their own, but IBM kept the roadmap, and we are now coming to, as far as IBM was concerned, we have developed 3 generations of the latest multi-core processors that are intensively used in HPC domain, as well as lower computing systems. So P10 is not existing yet, but P8 and P9 are successfully used, and as you might know, they are used in very large systems, as IBM won last year the 2 first processors in the top 500 classification in terms of capability of computation. So the co-optimization of software and hardware has always been something that we have been working around. Well, as we will see, this makes something that is coherent with the fact that IBM is and OpenPOWER contributors are well turned with open software, so it really makes sense to work together, hardware and software working together, to build industry-leading accelerated technologies. This is proven with Summit-like systems, and that can be deployable via a cloud operational model. So this collaboration is really something that open contributors are willing to live and to have in fact. So these different OpenX activities prove that there is really a major relationship between all these open contributors. So OpenBNC from the very low level of OpenPOWER system, OpenPOWER itself, OpenCompute, OpenCAPI, we will go into more details in the second presentations. Linux, obviously, and OpenStack. That shows that from top to bottom, there is really something that is coherent and that offers any contributor the capability to access at each layer, and he can get transparency and anything he needs at each level. So these are the main Linux support for OpenPOWERs. Red Hat now being part of IBM recently. SUSE and Ubuntu. Ubuntu and Red Hat are the most one that I know myself because I work mainly on OpenCAPI. CentOS being related to Red Hat, and Fedora, SUSE, and Debian, which are distributions that we probably well know all together. So same source and distribution release schedules synchronized with Intel worlds. The migration is very easy, and we have more and more customers who had in mind that IBM was still remaining in the big Indian area. So many customers are now very well positively surprised that they can seamlessly move from their x86 architecture to OpenPOWER or Power architecture. So as we said, hardware, software, and development, community feedback, we have all the way to run this openness. We will see some very little number of, because time is short, but one big example of a complete hardware defined for and with Google is a Dayus motherboard used in Google data centers. So it's a large system. We're using OpenBMC and different open contributions. On the very low computation capability side, it's like a PC size motherboard that Raptor, this company, is offering. So today they have an offer with CAPI 2, for example, capability, and 1 or 2 processors, multi-core from 4 to 44 cores per system, and this is a few grants for buying this kind of systems. So it's very easy for universities or students or at home to play with OpenPOWER capable systems, and you will get the same power system that you have in a Summit. So it's very good to know that you can scale and prepare things under your table, being in an OpenPOWER environment. Blackbird is announced too, and they also for the end of maybe early next year they will announce they will provide an OpenCAPI capable Power 9 based PC-like system. So Raptor is really a company that is promising on the very small system side. Of course, most of you know that Summit-like computers are huge clusters assembling many Power 9 servers and grouped so by 2. So a server is getting 2 Power 9. Each Power 9 is hooked up to 3 GPUs. So that makes a very huge number of GPU available, about almost 30,000. And the capability is simply huge for a number of nodes that is about 9,000. That makes 4,500 machines assembled and stacked together. So one machine here will have two P9 and six GPU inside. It's all water cooled, and I personally in my lab use the same version, but it's air cooled, so it has only 4 GPUs inside. But it's the same machine. Open Hardware main contributors to the two big computers, Sierra and Summit. So here we see the main names of people who have contributed to make this work for Lawrence Livermore Laboratory and Oak Ridge Laboratory as final users. OpenPOWER Foundation will go through what is the goal of the foundation. So here you can see that the statements of the foundation mainly aimed at facilitating members to share expertise, investment, and intellectual property to serve the evolving needs of all end users. So open, like we all know, serving evolving needs. It's open to customize and to adjust roadmaps. It's a governance that allows anyone to make proposals, and it's built on the well-known Power architecture. In early days, like 6 years ago, there were not so many contributors, and now it's much more known and appreciated. So we have lots of contacts and lots of very good contribution. In my side, as an OpenCAPI hardware engineer, I'm very pleased to work with chip contributors, with board contributors, and on the network side, working with Mellanox. We have really a very good ecosystem, and it broadens our mind. So we are not stuck into a single company, and we are obliged to think globally, and we're also obliged to address new needs in another manner compared to what many companies used to do before. So it's very interesting work to work on. That's very impressive to see that we have more than 300 members coming from 35 countries, 99 plus ISV, and we have, for example, more than 20 system manufacturers. So IBM was for sure the first one, but many people have joined, and there are many offering on the market, and they are proposing more than 40 platforms, from the simple one as we saw from Raptor to the larger one. That's very impressive, simply impressive, the work that has been done in few years. This slide, I was told it was not completely up to date. Again, this presentation is not mine. I collected that from the OpenPOWER members, so it might not be the latest one I got a few days ago. But you see the number of contributions. So we see the server side, we see the innovation side, the customer choice. Basically, as we saw earlier, we have different steps. So from top to bottom, we have the implementation, HPC, and research. We have the software layer contributors. We have the system integration contributors, the I/O contributors, the board system contributors, and the chip contributors. This is the use implementation from Google last year. We see that they chose this organization. They have put some companies who made some statement that they were very happy. I would mention Namix because we'll see in OpenCAPI that we have a very good contribution, not only on OpenCAPI, but Namix is a cloud provider. It's a small company, but it's very efficient and very reactive. They have very good access time, and they offer very good capability at very low cost to get tutorials or to get in touch with new technologies that you might not know, like the one we will talk in the next talk about OpenCAPI. So these are the priorities of for this year for the foundation. They want to make OpenPOWER a leading open technology platform through technology collaboration and mutual support. They want to grow the workloads and the software community optimizing on OpenPOWER, and they want to validate through adoption. conveyed via member and end user testimonials, use case, presentations, press and analyst reports. So the goal is going on well. We had very nice meeting, and each meeting that we have at OpenPOWER, it's very impressive that we see an increasing number of contributors. So the director asked how many people were coming for the first time. At least 1/3 yesterday were coming for the first time. So there is more and more interest in this open world. Focus area. I don't think there is much to say here, but that it's very growing. So there are lots of areas where we want to work on. So we want to improve the cloud access to get people not having hardware being able to discover the technology. We want to have training centers. They want to have working group, which is the case already. They want to interest more and more universities like you are, and we organize summits like the one we came from, and meetup, workshop, and so on. So that's lots of very, very promising activity around there that I propose that you follow on the side of your spectrum. Okay, I won't go that far on this one. And there are several work groups already began. So I personally work mainly on the acceleration side, and being in IBM, I'm also interested in the hardware side. So IBM is really helping a lot for making its very fast technology being used, and the last year have shown that the efficiency is really here, and that it's not just on paper that it's working, but it's really working on actual very huge loads. Okay, we spoke about events. So as I said, most continents are represented. Next meeting will occur in Lyon in France. That's very impressive for us. We are not a big country in France, but we are very happy to host the meeting in Lyon. There are at least once a year a meeting in Beijing, and once a year at least a meeting in USA, and one meeting in South Africa. So we have really, not South Africa, it's in New Zealand, but we have really all continents that are represented every year. Okay, that's mainly for. So this one we already been through. We have been through the fact that maybe most of you know that Moore's law is observing a limitation today, and providers of controllers, of microcontrollers, and providers of hardware are not offering the same increase of capacity each 2 years as we used to do before because of the technology restrictions. So there is a crazy, what do we say, race to try to find alternatives. And the GPU was one well known, but anything that could offer more computation capability is very, how do we say in English? Everybody looks for that. So in myself, as far as I'm concerned, working on FPGA is very amazing to see that like 20 or 30 years ago, FPGA were really a niche and really programmed by very specific hardware guys, and now we see that we are on the top on the front of the scene because they want to use this technology as it is very promising. So anything that could offer for the increasing need that the industry is offering, anything that could offer solutions is really appreciated. So we have an IT consumption that is going increasingly high. Not to say about artificial intelligence, obviously, hyperscale data centers, the cloud, hybrid cloud solutions, and the need for open solutions make a very drastic pressure on hardware and software. Data explosion is nothing to say that we see that every day in our everyday life. The modern workload adoption It's a well-known fact that most of the data is not usable as it should be, or it could be, or as we would like it to be. Artificial intelligence is very promising, but there are lots of limitations due to hardware and software not being infinite resource, and security. Obviously, to say that the more we exchange data, the more we are exposed to security issues. So the goal of the announcement was to say that IBM was willing to make a major contribution here. So the saying that the future would require that we build processor on a purpose. So we want to have a dedicated and specificity that are integrated into the future microcontrollers that will be on the market later on. There is a huge need of heterogeneous computing. We are assembling systems that are very heterogeneous. There is a huge need for open innovation. That is not an innovation that a company is pushing by itself, but it's an innovation that is desired by the customer themselves and the users. And there is also, on the other side, lots of pressure to get more and more things that are available and open. So this is the history of the relationship that IBM has established with the world, with the open world. So it's a major contributor for, as you know, for Eclipse, Linux. Red Hat was really a very good collaboration with them. IBM has contributed a lot into Kubernetes and Docker to help things going on the right way. And OpenStack also, we have been a major contributor. The fact that we have established OpenPOWER with a desire to push the power architecture as being a future unavoidable, very powerful architecture for HPC. The fact that we have created OpenCAPI based on the CAPI 1 and CAPI 2, as we will see in the next presentation. The fact that IBM has acquired Red Hat very recently, and they have announced yesterday that they would open the design, they will enter the open chip design area by opening the instruction set for the OpenPOWER, like for Power 9 currently. We will open reference designs, and we will enter in an open governance to help people organizing the future of roadmaps and so on. And OpenPOWER Foundation will be a subsection of the Linux Foundation, which is one of the well and best appreciated foundation for open software. So we'll expand open hardware ecosystem with major contribution to community. So the ISA, as we said, the instruction set architecture will be offered and to be accessed. Open reference design. So there will be, I understood it's not very clear to me because it's very new, but we will have today, I think, 4 subsets. One subset of a microcontroller would be a very basic scalar computer that will be able to load into an FPGA, for example, or to manufacture by yourself. And there are increasing 4 or 5 subsets that will be proposed. The most important thing also is the open governance. So through the new Linux Foundation, the OpenPOWER Foundation will be in open governance mode. So the fact that we opened this ISA is to have discovered this word. I'm sorry for my English. Unencumbered. I asked yesterday what it meant. Now I know. Unencumbered open innovation. So anybody would be have right to create, distribute, and license and sell Power ISA cores, ISA compatible cores. Implementation of the Power ISA represented by software, hardware description language, or integrated circuit design. A unified software ecosystem. So we prevent fracturing the Power's mature and extensive software ecosystem. We want to keep it in a current manner. Compliancy requiring to make physical implementations of Power ISA cores, a patent rights granted to make Power ISA compliant chips. So we expect that people will play the game and that all users will benefit from something that will be properly leaded in a very coherent manner. Freedom of choice, so as we said, there will be, for the beginning, 4 subsets of the architecture to choose from. The base compliancy, so you can derive from that and add or make modifications, provided that you have a mean to check, and we will provide a mean to check that you keep the compliancy. Optional implements additional compliant features, as I said. Architectural resources defined within ISA for custom extensions. So there will be lots of freedom to on the base to be able to fabricate and manufacture your own ISA-based system. And collaboration. OpenPOWER Foundation work groups with open governments inside the Linux Foundation. This will allow contributions for both OpenPOWER Foundation's members and non-members. That's very important. Any change that will break the backward compatibility would require a unanimous vote, but majority vote is sufficient for compatible changes. So it's very impressive, the fact that we are opening this. And this is a slide that we will mix again into the OpenCAPI presentation. So we are empowering the community to accelerate innovative new hardware built to address the challenges of modern workloads. Workloads being, as we said, heterogeneous, going from one side to another, from one server to another, from one FPGA, for example, to a GPU, to a CPU, to a compression hardware. So it's really a question of having the capability to stream and flow the data from one system to another. And IBM experience contribution to OpenPOWER is a key, because IBM has always been known as a very good I/O company, and we are very strong here, and this is what makes our system more valuable than what the competition can offer today. Good, so now you have in your hands, anybody, a student, a company can have in his hands anything from the very low-level hardware with the instruction set, the firmware and system, talking about OpenBMC or Linux kernel, and applications can be open too, and orchestration can also be with OpenStack, can be in your hands. So it's a very unprecedented, and I think it's an excellent news for all the technicians we are. Okay, that's it for most of the OpenPOWER presentation. I would appreciate if you have any question. If I cannot answer them, remember I'm a poor hardware guy, so if there are questions I cannot address, I would be very happy to collect them and forward them to my colleagues.